Let's do types of functions, and we discussed today domain and range. I'll give a summary of what kinds of functions we handle in the curriculum, and then we'll go. Typically we handle f of x, a squared function, f of x, a square root function. I'm giving the simplest version of the function. F of x can be a linear function which is x plus 5, an example I've given. F of x can be a reciprocal function which can be 1 by x. F of x can be a...
What is implied from domain implied function?
I'll come to that. F of x can be a exponential function which can be 2 raised to x. F of x can be an logarithmic function which ln x. ln x or log x, one of them we can use. Ln is to base e, log is to base 10. Now x square, if I say, then it's a squared function when I say. So domain is all about what is domain? The domain is set of x values for which y exists.
No, it's a set of, yeah, correct.
Domain is set of x values for which y exists. So I need to choose values of x for which y should be not infinite or undefined. Y should be defined. If you closely see any value I put in this case, any value of your choice of x, y will be defined. Y will not be infinite, y will not be undefined, y won't be upon 0, y won't be infinity. So these are the typical areas where we cannot say it is defined. So I can say all values of x possible. All values of x possible. Other way to say mathematically is x belongs to real numbers. When I say real numbers, it means all values possible. Now in case of this is all about domain. Range being squared function, we all know squared function can never be negative. Can never be negative. Even if you input a negative value, if you square it, it becomes positive. So we take any negative value, square it becomes positive. You take any positive value, square it becomes positive. Fraction value, square it positive. Even if you take x 0, even x is neither negative nor positive number, if you square it becomes positive. I mean 0, sorry, 0. Therefore, f of x, that is y, can never be negative. Obviously, never be negative implies it means always greater than or equal to 0. So range is y greater than or equal to 0. Range is set of y values for which x exists. X though every x value exists, but there is a constraint in y cannot be negative because of the square nature. So y is greater than or equal to 0. X belongs to this domain and range. Now let's move on to next function, which is square root function. Square root function is all about, we all know in from high school that square root of a negative number is not real.
So I thought all this was for this.
No, for this.
But minus 2 square is 4 only, and it's possible.
Yeah, so I said y is greater than or equal to 0. Where did I say? Y? I said y cannot be negative. Y is the other side. Minus 2 square is 4, 4 is positive.
Correct.
Minus 1 square is plus 1. 0 square is 0. 0 is 0. Except 0, other values of x input can give y positive. At x equals 0, y is 0. So connecting both becomes y greater than or equal to 0.
Okay.
Now root x is, x should be positive. X can't be negative. We always discuss negativity, 0 and positivity. I'm exploring x negative, x positive, yes possible. If you take 4 or 5, root 5, root 4, root 3, root 11, root 10, y exists. It gives a finite number. If you put root of 0 is 0, y exists. But if you, for x negative less than 0, y won't exist.
So it's undefined.
So by rule of domain, you cannot take x values for which y won't exist, because when x is negative, root of negative is a non-real number, because otherwise complex number, so not possible. Y can't be negative. So it's greater than or x greater than or equal to 0 is my domain. So don't say here real numbers, just say x greater than or equal to 0. And then next is y. Interesting. The range for this will be any input of x. As per the IB curriculum, we take it as plus root x. Plus root x. So root of 4 is plus 2.
So like in a graph also, if it's plus or minus, you take plus only.
Yes, because unless it is minus outside, you can't take minus. So plus, this is as per the curriculum I'm saying, plus root 4 is plus 2. Root of 9 plus 3. Root of 16 plus 4. I'm taking perfect square values. You can take any values. All I'm saying is when x is 0, y is 0. When x is other than 0, which is greater than or equal to 0, 2, 4, 9, any number you take, it will be y will be positive. So we can say range y greater than or equal to 0.
It's the same for
If you draw, you will understand that when x is 0, y is 0. When x is 1, 2, 3, 4, or you can say 2, 4, 6, 8, 10. Let's put x 0. When x is 1, y is 1. When x is 4, y is 2. When x is 9, y is 3. You can see the curve going like this.
It's not like an exponential curve.
No, not exponential. It's a gradual move. Okay. Exponential zooms. It's a gradual steady move. It's a curve, not exponential type. The gradient is quite less compared to the exponential curve. This is about root x. Next comes, are you clear about domain range root x?
Yeah.
Next comes f of x equals x plus y equals x plus y. We can call f of x as y. This is a linear function. We can say, because it is of the form x plus 5, it is ax plus b. So straight away it's a linear function. Linear function means any choice of x value will give me a finite value. Any choice of x value will give me a finite value, and the finite value means it will not be infinity, it will not be anything upon 0, it will not be minus infinity, it will not be 0 by 0, it will be a defined value. So I can say, the way I said earlier, any values of x possible. Any values of x possible implies x belongs to R. Mathematically speaking, x belongs to R. When I put any value of x, I don't have any restriction of y. Y keeps coming defined value. So there is no x value for which y is undefined, and there is no restriction on y side. No restriction. So I can say y belongs to R. Always, as a rule, linear functions, x is always belong to real numbers, y belong to real numbers. That's why when you draw this curve,
it can be anyhow.
When x is 0, y is 5. When y is 0, x is minus 5. If you connect both, it's a one-to-one function. It's a one-to-one function. This is about x plus 5. Now comes interesting reciprocal function. This is domain. Before I go to reciprocal, this is domain. This is range. Next comes reciprocal function. Why reciprocal? Because I see a variable in denominator. That's why it's called reciprocal function. You may have a variable numerator also. In this case, I have given 1, but you may have variable in numerator also. Nevertheless, reciprocal is only because I have a variable function or a variable in the denominator.
You did this last time, and this also.
Yes. Now, this is a scenario where I need to have some restriction, otherwise y may be not defined. If you take x equals 0, or for that matter, denominator equals 0, you know any numerator upon denominator 0 becomes undefined, not defined. Therefore, I should prevent x becoming 0. Prevent x becoming 0 means x not equal to 0. At the same time, I can put any value other than 0, y would exist, but for x equals 0. At x equals 0, y won't exist. So when I write, I can say x belongs to R. Why do I add this line? I'm ensuring that any value of x is possible other than 0. Both put together gives me domain. If I remove this, it becomes inclusive 0. If you remove this, I don't stress what is possible. By giving both, I say what all possible and what is not possible. This is about x value. Domain. Now range. Range is interesting. Range is a set of y values for which x exists. Suppose if I have y0, in a reciprocal function, look at y0 critically always. If y has to be 0, it has to be infinity down x value.
Okay.
I'm thinking reverse way. I'm initiating a value of y called as 0 and exploring whether what x will become. Infinity. So when y is 0, x tends to infinity. So y can't be 0 because x is undefined. As per the rule, range or y values for which x should exist, not existing. Therefore, y cannot be equal to 0. So range, y not equal to 0. Domain, x not equal to 0, x belongs to R. Y also belongs to R. So if you happen to draw this curve, when x is 0, it won't, let me start from 1. When x is 1, y is 1. When x is 2, y is 1 by 2. When x is 3, y is 1 by 3. It goes, when x is half, y is 2. So it is going like this. It won't touch x-axis. It won't touch y-axis. X-axis not touching means it's a horizontal asymptote, which is y equals 0. We know what is asymptote. Asymptote is a line for which the curve tends to touch but will not touch. So here the horizontal is y equals 0, the x-axis line. At the same time, the curve won't touch the y-axis. It's x equals 0. What is asymptote? X equals 0. Horizontal asymptote y equals 0. As a matter of fact, reciprocal functions will have synonymically the importance given to asymptotes, which we didn't have earlier. We didn't find in linear. We didn't find in square root. We didn't find in square function. But in reciprocal function, you will definitely find the significance of asymptotes, where the curve tending to touch a line but not touching the line. The line could be x-axis, line could be y-axis, line could be a line parallel to y-axis, the line could be parallel x-axis.
You were showing us like different types of asymptotes, like curved asymptotes and all. So that's
there are 3 types of asymptotes: vertical asymptote, horizontal asymptote, oblique asymptote.
So what is oblique?
A line which is, let's say, y equals x, the curve won't touch this. This is oblique asymptote. Although it might not touch even x-axis or y-axis, it neither touches an oblique line, which is y equals x. Y equals x is an oblique line, an inclined line. It's not a horizontal line, a vertical line.
Okay, so if you want to make like example of asymptotes, or oblique, horizontal, vertical, how do you make examples?
I'll tell you. I'll come to that. Yes. Now, 2 raised to x. Before I go to your question on asymptotes, I'll finish this first. We are left with 2 more functions, which is exponential function, which is 2 raised to x. Why I am saying exponential? Because constant down and variable up.
Correct.
Now, if I put x equals, I'm going to put random values of x and see x equals 1, I can put negative, I can put positive, I can put 0, I can put -2. I can put any choice of x values. 2 raised to that value will exist. x raised to minus 20, 2 will be, the y value will be very small, because 1 by 2 raised to 20. If I put x raised to 10, it will be, x is 10, 2 raised to 10 is 1024. So large value. So for any x value input, y will exist. At the same time, I can't get a negative y. Interesting. So let me come to first domain. The choice of x is unlimited.
Because x is real.
X belongs to real. Yes. When I start saying unlimited, all possible values, anything is possible, I am indirectly saying mathematically x belongs to R. Now come to y. It's very interesting. Y will be f of x. You won't find for any x input y negative. Okay. You won't find. You will ask me a question, sir, if I put x minus 5. X may be minus 5, but y in output is not minus, because 2 raised to minus 5 is 1 by 2 raised to 5. 1 by 2 raised to 5 is 1 by 32. As you increase the x values, as you decrease the x values, which can be even going negative, y will go close to 0, but not even 0. Forget about negative. Y will not even be 0. If x is minus 20, it will be a very small value, close to 0. Calci will tell you exact value, because 2 raised to minus 20 will become 1 by 2 raised to 20. 1 by 2 raised to 20 is a very small value, as being 2 raised to 20 is a very large value, so 1 by 2 raised to 20 is a small value, which will be very close to 0, but not 0. So, to summarize things, range
not equal to 0.
Y not equal to 0, definitely. Y not negative. So, other way of putting it to you, y always greater than 0. Y greater than 0. Sometimes some books call it as R plus positive real numbers. Strictly 0 is not even included in this. So why, if you draw a curve, you asked me a question that time. If you draw a curve, 0, 1, minus 1, 2 raised to minus 1, half, 2 raised to 0, 1, 2 raised to 1, 2, 2 raised to 2, 4. It increases exponentially.
Very fast.
Very fast. It increases drastically, substantially. For an incremental increase in x, there will be a substantial increase in y. This exponential behavior. But definitely the curve won't even touch x-axis. So obviously you are seeing asymptotic behavior as x tends to minus infinity, or larger values of negative, smaller values of negative, sorry, then you will have y tending to 0. This is so